Okay, in this lesson we're going to be working with some more similar triangles. So we know in this figure that line M is parallel to segment BC, and we first want to show that the two triangles are similar. So let's think about what we know here. So let's take a look at these parallel lines. Let me grab my pen here. So if I highlight these parallel lines, just extend them a little bit. If I were to draw in this transversal, remember what we learned about parallel lines cut by a transversal. We learned that alternate interior angles are congruent and corresponding angles are congruent. Now remember, we're trying to prove these triangles are similar, so I'm going to need some angles congruent. So let's see if we can figure out what some angles are that are congruent. So we just said corresponding angles because the lines are parallel. So I see that angle number 1, the one that's marked with a 1, that is in the same spot or a corresponding angle with this one here. So I'm going to mark that those two angles are congruent. Now, I can also take a look at the parallel lines that are already highlighted and the other transversal. And once again, two parallel lines cut by a transversal, then corresponding angles, and I'll just put a 2 mark there, corresponding angles are congruent. So now, if I'm looking at this top triangle, which I'm going to see if I can make that a different color, that top little triangle there, that triangle in red, versus the triangle that's already there, the big one in purple. Let me see if I can highlight that again. The one in purple right here. Okay, so those two triangles, we just proved that they are similar. And how did we prove that? Well, we have two pairs of angles. So that is angle, angle. So we proved that the two triangles are similar using the angle-angle similarity theorem. Okay? So now that we know that when we have a figure similar to that last one, that we know that we can set up a ratio and a proportion because those are similar triangles. Okay, so you don't have to prove every time that they're similar triangles, but we know that we have a diagram like that we're going to set up a proportion. So the easiest way to do that is actually to draw the two triangles separately so you can see the corresponding side lengths easier. So let's see if I can let's see here. Let's see if I can draw that separately. Okay, so now I got it. So I'm going to just draw that other triangle, the small one. I'm just going to draw it right beside. Okay, so triangle AED, just going to draw it right beside the large triangle. And when I'm looking at the large triangle, I'm looking at triangle ABC. Okay, so when we're writing our ratio or proportion, we have to be sure that we appropriately line up or match up the corresponding side lengths. So I'm going to say that 3 over the corresponding side in the large triangle, that's this whole side, that's going to be 8. Okay, I have to add the 3 and the 5. And that's equal to, now I'm going back to the small triangle, x over, and now I'm going back to the large triangle, and that's going to be this whole side length, which is x plus 8. So let's try and cross multiply and solve that. So we have 8 times x on the one diagonal is equal to 3 times the quantity x plus 8. So I'm going to go ahead and distribute that 3. So 8x equals 3x plus 24. And I'm going to subtract 3x from each side. So 5x is equal to 24. And dividing each side by 5, I'm getting that x is approximately, I'm going to divide 24 by 5. Let's see what we get here. 24 divided by 5 is 4.8. And I don't think we have any units here, so we'll just put units. So back to the small triangle, x is approximately 4.8 units. So that's supposed to be 4.8. Okay, so let's try another one. So we have another one here. Again, let's try to draw the two triangles separately. So if I grab my grabber here, I now am able to take a look at the two triangles separately. So now I can get my pen and set up the proportion. So I have, starting with the small triangle, let's say 4 over, now I'm coming back here, I want the corresponding side, which is going to be 4 plus 7, which is 11, is equal to, go back to the small triangle, 6 is segment AD, right here, over, I'm going to go back to the large triangle, I want the whole entire side length. So that's going to be 6 plus x. So there's my proportion. Let's cross multiply and solve that. So I have 4 times the quantity 6 plus x is equal to 6 times 11, which is 66. So distribute that 4. 4 times 6 is 24 plus 4 times x, 4x equals 66. So I'm going to subtract 24 from each side. So 66 minus 24 is 42. Okay, and then I'm going to divide each side by 4. And when I divide 42 by 4, I'm getting 10.5. And units. So x right here is 10.5 units. Okay. So now I'd like you to try some problems similar to those on your own. Go ahead and work on page 55, 1 through 6, and 51, all problems. Good luck.